We will now construct a D element by using two latches. The problem with the latch is that if we have the control signal 1, then there is a direct connection between the input and the output of the latch. So what we want to do is that we want to have a cascade of two latches instead. So in this case we have two latches, one called LM, where M is for master, and we have another latch LS, where S stands for slave. And then we have a control circuit C. And this control circuit gives us the two control signals to the latches. So we have the control signal phi1 to the first latch, and then we have the control signal phi2 to the second latch. And we're going to denote here the input to the first latch is X, the control signal is C. And then we also have the intermediate signal Z here, which is the output from the first latch and the input to the second latch. And then we have the output from our last latch, which is the output from our D element, which we're going to call Y. We want to build the control circuit C such that we never have a direct connection between X and Y in our D element. So we're going to have phi1 and phi2 to be 0, 1 if the control signal is 1, and then we're going to have them 1, 0 if the control signal is 0. This means that if C is 0, the first latch is letting the signal through from X to Z, but there is no signal that is passing the second latch because our phi2 is 0. Now if C is instead 1, there will be a signal that is letting through from Z to Y here because the second latch is open, but in this case, since phi1 is 0, the first latch is instead closed. And also, since we have a change in both variables at the same time here, phi1 and phi2, what we want to make sure is that when we make the transition from 0, 1 to 1, 0, and also back from 1, 0 to 0, 1, then we want to go through the combination 0, 0. So we want to make sure that we never have 1, 1. We can realize this with a more graph using the fact that we denote the state is phi1, phi2. So this is our state. And since we have a more graph, this will also be our output. And then the input to this state transition graph will be our control signal C. And note here that C is the control signal to our control unit here, while phi1 and phi2 are the control signals to the two latches that we have. So let us make our state transition graph. So we have the state 1, 0, which represents phi1 is 1 and phi2 is 0. We have the state 0, 0, where both phi1 and phi2 are 0. And then we have the state 0, 1, where phi1 is a 0 and phi2 is a 1. So if we are in state that we call 1, 0, and we have a 0 as an input, we're going to stay in this state. If we have a 1 as an input, we want to go to the state 0, 1, but we want to do this through the state 0, 0 in order to make sure that we never have the state 1, 1. And if we are in state 0, 1, and if we have a 1 as an input, we stay in this state. And if we have a 0 as an input, again we want to go to the state 1, 0, but we do that through the state 0, 0. And we can note here that this is an asynchronously realizable graph because each state and input has a successor state. So for the state 1, 0 and input 0, the state 1, 0 will be the successor state, and for the input 1, the state 0, 1 is the successor state. And similarly for the state 0, 1 with an input 0, we have 1, 0 as the successor state and 0, 1 as the successor state when input is 1. Now let us try to understand a little bit better what is happening here. So if we look at our state transition graph, our input signal is the one that we call C, and our state is the one that we call phi1 and phi2. In reality, C here will be the clock signal that we send to our D element. And using this clock signal, we are controlling the two latches through the control signals phi1 and phi2. So let us see what happens here in the time diagram. So during this time here, we are going to have that the clock signal is a 0, which means that we are in the state 1, 0, so phi1 is a 1 and phi2 is a 0. So the first latch, the one that we call the master, is now letting the signal X through to Z. So here Z equals X. Then here C will become 1, and for a very short time both phi1 and phi2 are 0 at the same time. And since phi1 here becomes 0, now Z is fixed to the value that X was before. So now this is fixed to the value that we called X0. Now at this time instance here, phi2 becomes 1, so the second latch, the one that we call the slave, opens. So it now lets the Z value here through to Y, and since Z equals X0, Y will now be X0. Then in this time instance here, our clock signal C will go back to 0, which means that our phi2 will now close again. And for a short time period here, both are closed at the same time, but then after some time phi1 opens, and again Z will be equal to X during this time that we have here. And Y will be the value Z0, which in turn was the value that Z had here when phi1 closed, which is our value X0. And then after some time C will go back to 1, which means that first phi1 closes here and we fix the value X to be X1. So Z here will be fixed to X1. And then here when phi2 opens, we will have Y equals Z. So let's see how we can make the realization of the control circuit. So we have the state transition graph here, which means that we need to make two Carnot maps, one for Q1 plus and one for Q2 plus. And since this is a Moore machine, our output will be the same as the state. So we could write immediately here that phi1 equals Q1 and phi2 equals Q2. So then let's fill in our Carnot maps. So if we are in state 0, 0 and we get a 0 as input, we go to the state 1, 0. If we have a 1 as an input, we go to the state 0, 1. If we are in the state 0, 1 and we get a 0 as an input, we go to 0, 0. And with a 1 as an input, we stay in 0, 1. We do not have state 1, 1, so these would be don't care terms. And for the state 1, 0, if we input a 0, we stay in the state 1, 0. And if we input a 1, we go to the state 0, 0. So we can see that only one prime implicant is needed for both of our Carnot maps. And we can write our function Q1 plus as Q2 prime C prime, and Q2 plus we can write as Q1 prime C. And for both of these we can use De Morgan's law to write this as Q2 or C and then prime, and this one we can write as Q1 or C prime prime. And if we realize this as an asynchronous sequential circuit, we will short circuit the connection between Q1 plus and Q1, which is this one, and we also short circuit the connection between Q2 plus and Q2. So this should be Q2 plus and this should be Q1 plus, but since we have an asynchronous sequential circuit, we don't have any D elements that separate these. So this will give us the realization of the C circuit here. So finally, this gives us a realization of our D element or our delay element. So we have the C circuit down here, which we used in order to produce the values phi1 and phi2, which are our control signals to our two latches. And here we have our two latches, so we have the master latch here and we have the slave latch here. So this is a complete realization of the asynchronous sequential circuit that we typically know as the D element.